Hello everybody, and welcome to the Graphs lecture. So here's what we're going to do. We are first going to talk about why we're talking about graphs. Then we're going to go over frequency distributions and scatter plots. So why are we talking about graphs in a statistics class? Well, graphs really give us a easy visualization of your data, at least the graphs we are going to be talking about. And it can help you get an idea of what your data look like. So if you come into a situation where you have a data set that you haven't used before, graphing your data will allow you to get to know your data a little bit more easily, especially if you have, let's say, thousands and thousands of entrances. You don't want to go through each and every one of those to make sure you know what's in the cells. So instead, what you'll want to do is get a quick visualization of it. It's similar to finding means and standard deviations, running your descriptive statistics, but this time you get to see what it's like, and there's something that's just different than that. And it can also help you catch errors. So, for example, in this case, I had a sample of students, and they answered how happy they were on a scale of 1 to 5, where 1 is not very happy and 5 is very happy. And if you graph the data in this box plot, all the way down here at the bottom, you see this negative 999. This is obviously not a 1 through 5 answer. So you know that there's some kind of error. Well, it turns out that I coded missing as negative 999. So negative 999 was my code for missing data. It told me that there was something missing here. And if you don't change that code for it, then it would really throw off your means and standard deviations. But the computer doesn't know. You just enter the data and you ask it to give you means and standard deviations, and it will give it to you. So if you don't visualize your data, if you don't check for these kinds of things, make sure you are doing each step along the way properly, then you can end up with errors, not because the computer got the numbers wrong, but because you might have forgot to do something. Additionally, some statistics can be easily checked with graphs. So, for example, correlations, you can pretty easily see the general direction strength of correlations by using scatter plots. You can also see if your means standard deviations are accurate with other types of graphs that we can get into. But it's a good way to check and see, do your statistics make any sense? So, let's look at these data here, these 40 data points, and just what can you tell me off the bat about them? Well, probably not a whole lot. You probably can tell that the numbers are generally in the 40s and 50s, but other than that, there's not a whole lot, unless you can, some kind of math genius, you probably can't get the means and standard deviations in a couple seconds. So one easy thing to do is to make a frequency distribution to help us understand what the data look like. So I'm going to give you the steps of frequency distributions, and then we'll go over each of them in turn. So the first thing we're going to do is we're going to find the lowest and highest scores from the entirety of the data set. Then we are going to record all of the possible scores in order. We're going to start by doing this vertically. Then we're going to go through the list of the scores. We're going to record all the scores, go through the list, and make check marks each time they occur. So if there's a 40, then you're going to make a check mark in your list of numbers on 40 and on the way down. And then we're just going to count up the number of checks to find the frequency. There's going to be a couple other things we're going to do in here, but this is generally speaking what we're going to do. So, first step, locate the lowest and highest scores. Well, I can tell you right now that the lowest is 40 and the highest is 59. If you don't believe me, you can go through and double check, but there we go. So we've got the lowest and highest scores. Now, we're going to record all of our possible scores in order. And I'm going to do this in Excel, so you don't have to deal with my handwriting, but you'll just do this on a piece of paper, and you can do it by hand. So for me, I've got the high score of 59, low score of 40, just in order down the line. So we've located the highest and lowest. We recorded all of them in order. Now we're going to go through the list of scores and make a check mark by each number. So we start out with 40. Well, we go back to our box and we can, or I'm sorry, our list, and we can put an X or a check mark or whatever by 40. Next one is 44. Put 1 in 44. Probably get the gist by now. 45. You put it next to 45. And then you'll keep going until you fill out the entirety of the scores. Now, what can you tell me about the data? Well, probably a lot more than before, right? The numbers, the most frequent one is 46. That's the mode. They kind of converge around there. That seems to be at 45, 46, 47-ish area is around where you might think the average would be. And you can also tell, well, we've got this 59 that is somewhat of an outlier, right? The next closest score is 52. I did not, well, I would not have noticed that outlier if I hadn't done this. So, again, here are all of the steps in order. And we're going to last check the number of, or count the number of checks to find the frequency. So now you have your frequencies down here, can give you a better idea of what exactly is going on with your data set. Okay, now, one of the things I want to point out is why I told you to put all of them in order and not just put them in the order when they showed up. And that's because if you do that, you might have left out 53 through 59. And there is a difference when you see these two, the graphs, where you can actually see how much of an outlier the statistics are. So the next thing we're going to do is grouped frequency distributions. And we're going to do grouped frequency distributions for reasons that will be more apparent in a little bit, but primarily because sometimes you don't want to put every single possible value in there. So if you're dealing with income, you don't want to have a row in your graph for the income of 1 cent, then 2 cents, then 3, and then all the way up to however many hundreds of millions of dollars someone makes. So you can do grouped frequency distributions for that. So generally speaking, what you want to do is as follows. You're going to find the lowest and highest scores in the data set, subtract the lowest from highest. Then you want to determine the interval. So that means how many values are going to be counted in one bar on your chart. And usually we have 10 to 20 or so. That's the easiest, or an easy way for you to visualize it. Then you need to determine the starting point for the lowest interval, record all of the possible intervals, and go through the list of scores. And I'm going to trust that because we've already done frequency distributions, some of the steps of grouped frequency distributions I'm not going to go through in as much detail because they're very, very similar. So let's take our data. Well, we've already got the lowest and highest scores. We got 40 to 59. And subtract the lowest from highest. So 59, I'm sorry, subtract the highest from lowest. So 59 minus 40 is 19. Then we need to determine our interval. We want 10 to 20 intervals. So if we have 40 numbers, we'll use 2, and that will give us 20 of them. And then we need to determine the starting point for the lowest interval. So 40 to 41 is the lowest interval. And then we need to record all of our possible intervals in order, like we did all of our numbers along a y-axis. So we can finally go through and make check marks just like we did before once we have that set up. And when you do that, it'll look something like this. So we have 40 to 41 happens 3 times. So you'd put both values that are 40 and 41, you'd put checks in that interval, 42 to 43 that way, etc., all the way down the line. Now you can see the difference between a frequency distribution and a grouped frequency distribution. What does it do? Well, one of the things that it can do is it can help smooth out some of the outliers. So for example, the largest interval here is still 46 to 47. 46 was the one that occurred the most frequently previously. 47 did not. It didn't occur as much as you might think. But when we smooth it out a little bit, it is still popping up in the largest interval. And this gives a kind of fewer ebbs and flows. It's a little bit more naturally curved. So if you just flipped 51 and 48 and 49, there's only one really time where this doesn't look almost normally distributed. This side goes up smoothly. Whereas over here, it starts up, down, up, down, up, down, up, down. So in this way, you can get a grouped frequency distribution. And this is often done, as I said before, with things like income, where there are huge intervals. So these intervals are very large because you have a large amount of spread in income. So going from less than $5,000 a year to $250,000 or more, you could have a million intervals in here. You can have many, many intervals. And so instead, group some of them and you can get a picture like this. You can also turn your frequency distributions from being frequency distributions going out towards from the y-axis out to going from the x-axis up and look like a histogram. And sometimes you might want to do it in that way. And when you are doing this, all you really do is the same steps, except just do it horizontally. Oh, I'm sorry, horizontally instead of vertically. So it's not actually very complicated. You really just, instead of putting the numbers along the y-axis, you would put them along the x-axis. When you do that, you can get a frequency distribution like this, and you can get more fancy, and you can do other ways of doing it as well once you've got your data plotted. And then finally, frequency distributions can be done with all types of data you have: nominal, ordinal, interval, and ratio. So it'll work for males and females, tell you the number in each. It can tell you the number of people who won gold, silvers, and bronze. You can see the number of people who have different IQs in some distribution, or height in inches. Any type of scale that you have, you can use a frequency distribution for. Frequency distributions are the most flexible types of, well, one of the most flexible types of graphs. Now, we're doing this with one variable at a time. How would we do this with two variables? Well, if you want to do it with two variables, you use scatter plots. And scatter plots are just easy ways to see the relationship between two variables. And you can see how the relationship goes with the two variables, either as one goes up, the other goes down, or it doesn't change. So it either is going to have a variable going up, down, or no change between the two of them. And you can also see how closely related variables are. So for example, if we had height and weight, these five people who I just made up, we could see a scatter plot like this. And you could see the general trend that as people get taller, they weigh more. This is not surprising, especially in made-up data. But this idea of getting a visual representation of the data could be helpful. It might be weird to you. It might set off some alarms if instead of a positive relationship between height and weight, you saw that weight was negatively related to height. That would probably be weird and could be an easy way for you to check and see maybe one of your variables is reverse coded. Maybe there's some kind of error in how you entered the data. There could be something going on there. So if we have this example, the relationship between height and weight, here are our steps. So we are first going to draw a right angle with lines extending up and to the right. Then we are going to find the lowest and highest value for each variable, and these are going to be our anchors for our axes. We're going to determine if there is a variable of interest or an independent variable, because it will depend on which axis we put each of our variables. You're going to plot your anchors and then plot your points. So let's go through it now. So in this example here, if we want to just draw a right angle, this is how it's going to be with all of them. You have yourself a right angle. Good job. Now the second one, find the lowest and highest value for each variable. Well, for height, the lowest value is 62 and the highest is 79. Whereas for weight, the lowest value is 130 and the highest is 275. And once you've found them, you could plot with those being your anchors all the way to the left and to the bottom of your graph. But what I would like to do is find some kind of large roundish number that you can use so your data are somewhat separate from the axes, and you'll see this in a moment. So for us, let's, instead of using 62 and 79 as our anchors, let's use 60 and 80, and then for weight, instead of 130 and 275, let's use 100 and 300 for weight. So once you've found the variables, now the high and lows of the variables, we have to determine if there is a variable of interest or an independent variable. And in this case, when we're doing scatter plots, the independent variable, the variable of interest, is going to be along your x-axis, and the dependent variables are on the y-axis. That's just convention. That's just how we do things. Now, if neither of them qualify, if you just have two random variables, then A, I might not know why you're running a correlation, but B, you can just choose which one it is. But in our case, is it more likely that height causes weight or weight causes height? Well, just because you gain weight doesn't mean you get taller, trust me. So it's much more likely that as you get taller, you weigh more. So in this case, since height is more likely to cause weight, then weight cause height. Height is our IV, and weight is our dV. So height will be along the x-axis, and weight will be along the y-axis. So now we just plot our anchors on our x and y-axis. So we have 60 and 80, and 100 and 300. And then finally, we're going to plot our points. So you can go through and say, okay, we have one value of 70, that's right around here, and another that's 215, that's going to be somewhere around here. And you'll just put an X or a dot or whatever you want. For 62 and 143, 62 is about here, 143 is around here. Well, you could do it this way, but you can also give yourself a little bit more help by making some grid lines in here. So, for example, if you were to plot 60 and 80 and have 65, 70, 75 along the way, and from 100 to 300 have these values along, it could be more helpful for you to be able to say 70, 215, well, we got 70 already there, 215 is right there. And this is also why I said you should get whole numbers, because it'll be easier for you to go and decide the middle value just being another whole value instead of, let's say, the 71.5 or something like that. It's just a little cleaner for people to understand and for you to get through. Once you've plotted them, now you can say a lot more about the data. It looks like there's a pretty strong positive relationship. And in this case, I wanted to keep the graph pretty clean, so I only did these 5 points, but you can have thousands of points on here. You might not want to use scatter plot in that way, but it can still be helpful to visualize your data like this. So to review, frequency distributions and scatter plots are just basic ways to help you visualize your data. And they can be used to get a visual summary of your data to help familiarize yourself with it or to help spot problems. Additionally, there are many, many more types of graphs. Obviously, we're just doing a couple of these because I think they're particularly useful for where we are. But if you were to go forward, many, many more types that can be really helpful to you as well. Now, what should you be able to do at this point? Well, I want you to be able to make a frequency distribution, make a scatter plot, and also, because of my emphasis in theory and understand why we're doing what we're doing, I want you to understand why we are doing both of them and what they can tell you.